Okay, this is task 2. You should have just barely done task 1. Okay, this task 2, there's a lot of words on this page, but what I did is I added in here, there's a little bit of information at the top of your page, I think on 236, I think this is on page 236, that I explained in the video notes a little bit, but I wanted to repeat. We have a dot. A dot is sometimes used instead of the symbol X to represent multiplication. Now, why, you might ask? This will make more sense later when we use an X to represent like a mystery number, a number that we don't know. So sometimes it can be confusing to have an X for multiplication and an X to mean something else. And so sometimes it's just easier and is clearer to use a dot for multiplication instead. You just have to remember that the dot does not look too much like a decimal, that you put it in the middle a little bit higher than you would put a decimal point, and you put your numbers, you spread them out just a little bit. Okay, so we have 5 repeated factors here for these 7s. We have 7 times 7 times 7 times 7 times 7. And we just have the dots in between the 7s to represent multiplication. And since there are 5 of them, we have our base number is 7, and then it's raised to the number of times that you multiply it. So you multiply it 5 times, you put a 5 as the exponent. Okay. And then there are 2 specialty names for some powers that I explained too. That 8 to the second power could be read as 8 to the second power or as 8 squared. And 9 to the third could be read as 9 to the third power or as 9 cubed. That only works if you have it to the power of 2 or the power of 3. Everything else more than that, 4, 5, 6, and on, is, the base to the whatever number power. Okay, now on to the problem. For number 2, we have an exponent tells how many times a number is used in an expression. So look at the expression 5 times 5 times 5 times 5. How many times is the factor 5 used? Well, we just count how many times 5 is used, which would be 1, 2, 3, 4. 4 times. Okay. And then we're going to complete each statement for part B. We have 5 times 5 times 5 times 5. Blah, blah, blah. So it's 4 times. So it's going to be 5 to the 4th power. And for the second one, it's 8 times 8 times 8 times 8 times 8. So there are 5 8s. So it's going to be 8 to the 5th power. Okay, for part C, we're going to write an equation. Write an equivalent repeated multiplication expression to, 23. Well, 23, whenever we see 23 just by itself, then that means that it is not multiplied by anything. So we can just do 23 like that. Let's write 123 in there. Now the 23, another way that we can write this is 23 to the 1st power. Because that 1 just represents, you just have 1, 23. So 23 to the 1st power is equal to just 23. Okay, for the second one, we have 1/3 to the 5th power. Oh no, what do we do with fractions? Well, when we do a fraction to a power, we have to make sure that we put the parentheses around the entire 1/3, because then that 1/3 together is raised to the 5th power. Whatever's in those parentheses, you're going to multiply 5 times. So it would be 1/3 times 1/3 times 1/3 times 1/3. And it looks like we only have 4 here, so we gotta make another space. Times 1/3. This also goes for a problem if we see, let's say we see 2 plus 3 in parentheses, and it's raised to the 2nd power, or it's squared. That is written as, because we do our parentheses first, our order of operations says we do parentheses, that we're going to do 2 plus 3, we can write this two ways. We can do 2 plus 3 times 2 plus 3 because it's twice. Or we can do the parentheses first, 2 plus 3, which is 5. So then it would be 5 times 5. Both of those are the same.